Hey there, Dengar Stu here. Today's video is about installing my new Raymarine VHF radio and is proudly sponsored by MarineEngine.com. So, you've probably seen this one in the background for a while, finally got around to editing this video. Previously, on the boat, I only had a little handheld VHF radio, and we now have a built-in VHF radio with an external antenna. I was very fortunate to have John come on board from Raymarine and teach me some of the finer points about installing their equipment. There's a lot of things you can do during the installation phase that make sure you sort of get the best out of the unit itself down the track. We're going to be putting quite a lot of Raymarine gear on the boat for the cruise up north. A lot of things to make the trip safer. Radio being, case in point, but also autopilot, it's going to make it much more comfortable, as well as radar and some infrared cameras, etc. This video is going to focus on installing the VHF radio and tuning the antenna to go with it. In order to get this radio installed, I actually installed quite a lot of equipment in the sense that we now have a C-Talk NG backbone, which is an NMEA 2000 network, and I have the AIS installed, all these kinds of things, but I don't want to sort of load you with everything at once. There's a lot to learn, and I think it's good to have the videos sort of kept on themes. So, down the track, we will be talking about how NMEA and the STNG network works, and doing a separate video specifically on the AIS, which operates in the VHF sort of spectrum, very similar to the radio, and then we'll be going on and doing radar, etc. So if you see things installed that aren't talked about in this video, fear not, they will be coming in future videos. Now, I've got a plan of all the Raymarine gear I intend to be installing onto Renko for cruising. So I'll show you that now so you get a sense of what the future plans are, which may help sort of what's happening in the short term make more sense. So this is the master plan. Quite a lot of bits and bobs that all interact very cleverly to give you some really good features when you're cruising. What we are doing today is essentially installing the Ray63 radio and the VHF antenna to go with it. As you can see down here, we have this STNG or NMEA 2000 network that's connecting all these different devices together, which we'll be talking about in detail in a separate video. I'm also going to be installing an Ethernet network on the boat. This is really good for high bandwidth applications such as cameras, which we'll be using both for cruising and probably for making YouTube videos, radar, and also if you end up linking multiple multifunction displays in different locations. For now though, we're going to stick to just installing the radio and the antenna, but there's a lot to learn about both installing this equipment and using this equipment, so I'm going to sort of divide it into bite-sized chunks, as I said. Before we go back and meet up with John and start doing this installation, I'll just quickly explain how radio actually works. The best way to understand radio is to picture a cat. Then if you pull the tail here, a meow comes out the other end. Radio works in exactly the same way, except with radio, there's no cat. All right, now I'll let John take over and explain some of the simpler stuff. John and I have just been talking about where to put the Ray63. One of the things John said is, well, two things really. One is that you don't really need to see the screen all the time. You've got up and down on your handset, even though this particular one doesn't have a display. But this unit does have an external port for, what was it called?
Yeah, it's the Raymarine handset.
Raymarine.
So plugged in the back here, extension cable, bulkhead plug, and it has a slightly oversized handset that has a window in it. Mm-hmm. So you can mount this in one location and have the second station somewhere else. Yep. So you might have this inside the cabin here, and the second one you might have somewhere outside or somewhere else that you feel you
down
may
in the cabin
need
where you're sleeping or whatever.
Yeah, something like that. So that is part of the reason why we helped Stuart select this particular radio. So as a standalone, it will work as a brilliant radio, but there is that option there to add that external Raymarine handset, just redundancy.
And it's a cable that then goes to like a bulkhead socket, you're saying, so you
Correct.
can run it quite a long way,
yeah,
and then just have a short lead.
Yeah, they're set lengths. From memory, there's something like 5 meters, 10 meters,
right,
and 15 meters.
Yeah. So longer than the boat.
Yeah. So people, if they've got sort of a side control station or a fly bridge or something like that, they often put the second handset in those locations.
Makes perfect sense, yeah.
even though these have got moisture protection ratings, it's always good to keep them out of the elements if you can, and that handset is somewhere else. But also it allows you that flexibility. If you want to add that in the future, you can do that. So that's a good thing to consider.
It is good to know, and it certainly comes into consideration, which is the thing now, about where do we put it. We were toying with the idea of being next to
here potentially, or
but the issue there is running of the cables next to each other, and you're saying there's an AC element to this.
Yeah, so we're running a VHF antenna here, which is designed to pick up AC signals for the most part. And we've also got our transducer cable running down in behind the multifunction display, and it's using sort of pulsed AC type signals as well. So can't say it's definitely going to interfere, but there's a potential.
Ideally we should...
If we can avoid it, let's run it down a different path. So,
you can have a single sort of compromise antenna for VHF and AIS, but we're talking about having a separate antenna, but having them broad enough that if the VHF antenna dies, we can swap the AIS antenna over without even leaving the cabin to give us redundancy, which is good for a cruising boat. I don't know, actually now I'm thinking that could be really nice.
Yeah, that's looking pretty good, and that's from an accessibility point of view. I mean, we could mount the AIS wherever we wanted. We were thinking over here, it could be somewhere else.
Could be on that side.
I guess that's going to get our antenna connections even closer together, so we don't need to do a joiner cable as a temporary or something like that. So that may be quite a good option. Bearing in mind the AIS does also have a built-in splitter, so that's another option altogether. So
that's if you've just got the single wideband antenna?
Correct. If you're using a single wideband antenna, you plug it in the antenna port, this other port goes off to your VHF radio.
Right.
So your AIS is using the main antenna, but you're splitting off to the VHF radio, so thereby you're sharing one antenna. We do need to make sure that we do actually have a wide enough coverage on that antenna. So AIS operates in around about the 162 megahertz band. VHF is around about 156 to 157. So most VHF antennas are very good at channel 16, which is 156.8.
Centered around.
And they spread a little bit beyond that, but I have seen some antennas where at 162.025, where a lot of the Class B traffic occurs, the response of that antenna may be very, very poor.
Alright, so let's have a quick... I think we've decided on a spot, which means I can put that back up no problem. And it means we can definitely get under here, but we can get away from those cables. We can just drill another hole through the timber more easily than here. And we can drill a big hole for pre-terminated UHF connectors, antenna connectors. So let's have a quick look at what cables we've got on the back that we need to connect, maybe.
Okay, yeah, let's do that.
So what do we got here?
Yeah, so looking at the back of the unit, firstly the most important one is the power feed, and that's a 12 volt DC. We've got a fuse in here, which we just check to make sure it's okay. It's supplied with the product. On the second outlet here, this is for integration with older products, where we're using the older NMEA standard, the NMEA 0183. So if we had an older chart plotter or some other device that we wanted to send any data to, GPS related information, or receive GPS related data, we can do that via these. With the current setup, we're going to stick with NMEA 2000, which in Raymarine language is STNG, which is more about our cables and connectors. So these would not be used in your case, so we just make sure they're nicely insulated and out of the way. Here there is an RCA plug, and this will provide an outlet if you wanted to add an additional speaker.
Oh, right, okay.
Or you can feed that to a stereo system or something like that.
So it's just a line level output for an amplifier?
Yeah, line level more or less. It's something in the order of about 1 or 2 watts, depending on what impedance your output is.
Okay.
But yeah, very, very small output there that can be used.
No, that's good.
Behind this plug here is the connector we were talking about earlier, and this is where you would plug in that additional handset if you wanted to use that.
Okay, yep.
Otherwise you leave the plug in there, and no harm. Over here we have our connection for our VHF antenna, and that's sort of what's commonly referred to as a UHF connector, PL239 or an SO259, I forget which is which, but something in that area. But really quite common. We, as a company, try to avoid bare wire connections or terminations in the field. That increases the reliability of the product. As a lot of people think they can do it, but sometimes don't necessarily test it, and we find that can cause all sorts of problems. So definitely, if you can buy a pre-terminated cable and the manufacturer has done that and tested it at manufacture, then by all means plug that into here. Only as an absolute last resort would you make that termination. So same would go with our connector over here. This is the C-Talk NG, or STNG as it's commonly referred to. Again, they are pre-terminated cables, as you would see here. So there's a small O-ring in here. They're sort of designed to keep excess moisture out of there, and this would then feed into that NMEA 2000 or STNG backbone.
So the STNG is the Raymarine sort of plug standard, but it's electrically compatible, identical to the NMEA 2000 standard.
Correct. I mean, there's a lot more information on this, but the NMEA organisation came up with this standard for NMEA 2000 communications. STNG is Raymarine's variant of the cables and connectors, so electrically it complies.
Yeah, so it's a superset of it.
Correct, but we're using these cables and connectors. So the NMEA 2000 standard uses mostly what's referred to as a micro C connector, which is this particular connector here.
Okay, yep.
And that often means that there's a number of T-pieces, and they're generally all black in colour.
Right.
Very easy to get it wrong.
Okay.
And with using the STNG standard, it's a little bit easier to get it right. So we've got the white cables, they go to the products.
Right.
Blue cables, blue backbone. So
I did notice that when we were doing the Axiom element in Dave's trawler.
Yes.
We had the little backbone, and I just followed the colour coding. I couldn't get it wrong. It was good.
So I mean, the main thing about this is we don't want to be cutting and splicing cables. So we want to use complete cables. If we decide here that this is not long enough, there are other variations of this, which is commonly referred to as a spur cable, or in DeviceNet terminology, that's also referred to as a drop. So that goes to our devices and joins into the backbone. If this is not long enough, we can buy a 1 metre, 3 metre. Around about 5 metres, we need to question whether we should be using a spur. Because the longer lengths should be done with a backbone. But when we come to set that up, we can go into a little bit more detail on how that works, about how to get
Yeah, that'd be good actually, because there's a lot of, although, NMEA's been around for a long time, I don't come across many boats with it installed yet, particularly boats in sort of the budget my friends tend to have. I'm sure the big Rivieras do or whatever, but so it'd be nice to learn more about that for sure. Yeah.
So I mean, that can just be a simple connection between a radio and your multifunction display. So that any sort of distress alerts that are received by the radio can be shared with the multifunction display. So that, as a boatie, we want to offer assistance if we can.
So obviously there's a lot more, compared to an average analog VHF radio, this does a lot more, given it has a digital connection to the multifunction display.
Yes, it does. So for your DSC function to work correctly, you need to have a valid GPS input to the radio.
Right, okay.
So it can be received from the multifunction display.
This radio can send distress call information to the Axiom, and the Axiom can send GPS information to the radio. It's a...
Yes. So those distress calls, they would be received from other people around us who may have made those calls requesting assistance, and then you can actually use that waypoint to navigate to that person. Yep. Assuming the sea hasn't swept them away.
Okay, so that call, when they do a DSC call, so a digital select calling, is it? Like a distress call, that actually sends the GPS coordinates of the person making the call?
If you're using the emergency distress button, which we didn't go into the front of the product too much, but in here we have our main control knob is sort of a multi-function type of knob, does menu. We've got our volume and squelch, so by pushing it in and rotating it we can get different functions out of this button, and then there's just usual control going straight to 16 here. But under here, if you lift this flap up and you press that distress button, press and hold that distress button, if you have input a valid MMSI number into here and it's got the GPS fix, and of course our VHF antenna is happy, then we should send that message out. So anyone in our vicinity or anyone within RF range can receive that and offer assistance as we would all.
And they all receive the fact that we're in trouble, the name of our boat from the MMSI? Because that's attached, isn't it?
Not necessarily the name of the boat. It's usually the MMSI number and the position of the vessel.
Right,
and the fact
GPS position. And then AMSA can take the MMSI and look the record up and
yes, that can be done. So that can be done by other people, but your average fellow boater is just going to see that there is a vessel in distress that needs assistance, and this is its particular lat long.
And if I receive one, the position of the boat will appear on the chart?
Yes, it comes up on the chart, and it will, flashing to you, give you a warning box, and then you can either accept it or decline it.
Yeah, right, that's very cool.
That we look after.
So it's kind of just an alternative to, it's almost like your EPIRB is, both satellites are going to be anywhere in the ocean, but if you weren't in extreme danger, rather than setting that off, I'd be more inclined to do your distress on your radio first, and then...
That's it. Most people will then, as you create your own plan for what happens when this occurs, one of your first things may be let out that distress on here. So we can alert fellow boaters that we're in trouble.
Yep.
And then after that, if we don't see any assistance or we have no indication that there's any assistance coming towards us, that's when you move to your next course of action. And usually people would opt to, let off their EPIRB.
And I guess that's the thing, there could be a boat 1 mile away you can see. You set off your EPIRB, they don't know that's happened.
Yeah.
They got no idea. AMSA knows, but that boat doesn't. So
no, that's right.
Yeah.
And so the other thing about this distress thing is this is going to give the lat long at the time you press the button.
Yes.
And we know that these things usually go down when there's waves over the roof and all sorts of wind howling and all sorts of things. So by the time you do that, and by the time someone responds, you're so far away from where that is.
Yeah, gotcha.
And this is where the AIS is helpful, because if that person who's responding has an AIS receiver and you're transmitting your position report, when they get close to you, they're going to be able to track you on the AIS.
We're going to get some power to this radio, but John made this comment of we need to confirm it's actually DC, which started a whole new conversation. So what about power?
Okay, so the unit needs 12 volts DC, and that's a nominal 12 volts DC. So we need to make sure it's in the acceptable marine range. So that's generally sort of around about 10-ish volts to about 15-ish volts. But it needs to be DC. So DC, when you look at DC, it should be like a railroad track between 0 volts and 12 volts, railroad track. As soon as we start adding other circuits into that, then it can be anything other than that. So we can get a little bit of ripple on it from a charging circuit, or a little bit of AC over the top of it as well, or we might even just get a bit of funky mess on it. So any of those things, they can have different effects on the unit. So that's that it's DC. The other thing is that it needs to be able to sustain the current. So when we press the transmit button and we want full power, it can draw up to 6 amps. We need to make sure that it can provide 6 amps without the voltage dropping away. That's going to ensure that our cabling, connectors, battery switches and whatever else might be in that path between the battery and the product is healthy and able to sustain that current. So that means that when we press that button to call for help, it's all going to happen. So we can do a measure with the system as the boat is at the moment on the mooring. It would be also wise to do similar tests when the boat's underway or different circuits are in operation, nighttime, daytime. That way we can be satisfied that we're getting a healthy supply. Now the main way the best way to measure that is using an oscilloscope. So an oscilloscope used to be a crow, which used to be a big box that sat on someone's bench, but now you can get them in a scope meter. Now this is my particular scope meter, and I've tried a number of different ones. This one's very easy to use, so I use this one. Cool, so what we've got here is we've got the measured voltage up the top there, the 13.3-ish volts. And down the bottom here we've got this little marker just alongside my finger. That's where our 0 volt reference is. I've just scaled it so it fits in the screen. The blob on the right hand side is where I dropped the meter once before, so don't worry about that. If we go too fine with a time scale, we will start to see all sorts of AC and all sorts of other junk on there. And we'll start concerning ourselves with things that are not really a problem. So about 10 milliseconds is about where we want to measure this. But what we're looking for is that line below the 13.3 volts. We want to see it's flat, and as you can see, every so often we're getting these little movements on that, and they're just changes to our supply. That's just sort of something that's happening with the circuit potentially turning on or off, or something to do with our charging supply coming through. But looking at this, I wouldn't be overly concerned with that. That looks fairly normal. So we can see it is charging, and I'm assuming that's coming from the solar panel or panels up on the roof or something like that. 13.3 volts is a fairly healthy charge. If this was not charging, we would expect this to be a healthy charged battery, 12.5 volts or somewhere in that area. So this is fine. So we're at the panel here. The next step would be to run a cable, even if that's a temporary cable or whatever it is, up to the radio, take a measure at the other end, and we'll apply a load on it and see that it's going to maintain that 13.3 volts.
We're going to test the unit just because it's going to take me ages to wire it on an external power supply that John's got. But he just made a really good point, which is when you're looking for a fault in a unit on a boat, he'll often just go to his totally independent power supply and see if the problem goes away. And if it does, it's a problem, with the boat, the power supply on the boat. So it's actually quite a good diagnostic technique as well. I like that.
Yeah. So just as a comparison with our scope measure, we've got the same scaling and everything. If we just measure on here, this is just a little lithium battery pack that's just got a sort of a breakout board, a fuse, but we can see this is a flat line 12 volts. So
there's no ripple, and it's 12.07, so a really good 12 volt too.
That's an absolute railroad. So that's true DC. A battery is true DC. What we're going to do here is, it's a bit cleaner to set it up here, and then Stuart can run it in later, is we'll use this battery pack and we'll connect up the radio, and we can do a couple of tests here at least to make sure everything's functioning fine. And we can come up with a plan as to how it needs to be installed, and we can go from there. We've just connected it up temporarily to the radio, and we've put the meter in line with it, so it's in parallel. So we can use the scope to measure that supply. See, my battery's probably a little bit flatter than it should be, but 11.85. If we just substitute whatever the vessel supply will be once it's installed, then we're all good. Now, if we then go to push to torque, we've got a dummy load on here, so we're not going to transmit, and I've got my VSWR meter on there.
Oh, right, this is your dummy load here on the end.
Gotcha. This is a smaller dummy load. This is only 5 watts. It's more about heat dissipation for that. What that does is takes the place of a real antenna, so we're not actually transmitting, because it's not ideal to be transmitting directly at our heads, but also we shouldn't transmit with it open with no loading on it either. You can damage the radio in doing that. So a couple of things we're looking for here. We want to do a measure of the voltage drop on here. I'm expecting this battery pack may not deliver as much as we hope, but we also want to see what our power output and what our VSWR measure is with that dummy load, and then we can compare that to the real antenna once it's installed. So if we're just going to press the push to torque button, and we can see that's pulling down. I can release that, and we'll see it going up. So we're going from 11.9 down to 10.85.
We've got our antenna just running through the door for now. I'll fix it up when once John's gone, so I don't keep him too long.
Yep.
But we're looking at testing the antenna now, are we?
That's right. So what we want to do is, the antenna, according to its specs that came with the product, suggests that it should be low 1 to 1 or 1.25 to 1 or somewhere in that vicinity. We know that the mounting environment can affect that, so we want to check that that's all good. Now we've got it on the radio, we want to see that we've still got a good result, and then our final test is going to be, we'll make contact with the local marine rescue or another boatie, and we'll see if we get a good response from that.
And just for those who don't know, so the 1-to-1, you're talking about this, the VSWR?
Correct. So what that is as we put the power up to the antenna, the idea is that antenna should resonate at that particular frequency, and all of that energy should be sent out to somebody else. It's normal for there to be something reflected back to us. So if it was 100% output, we would get a 1-to-1, which means that 100% of the power we're putting out is being transmitted out into the air around us. If we get something sent back to us, then there's this ratio between output versus reflected. Usual VSWR up to around about 2-to-1 is about what we'd consider acceptable. Depends on your antenna and so forth, but usually around about 1.5-to-1 is what we might expect to see. If we're above 2-to-1, then we want to look at the mounting environment, we want to look at the antenna, we want to look at the connectors and see what we can discover there. But that VSWR needs to be measured at a specific frequency. So this is a very broad frequency antenna that's been selected here. So it should cover the 156 band, the lower end of VHF, and should go all the way up to the AIS at 162.
Went with the Pacific Aerials antenna from New Zealand, Damien Land, and yeah, got really good SWR results in it, so that's very pleasing. Next job was to install a cable gland so that they could run the aerial lead down through the wheelhouse roof without water getting in as well. All right, there we go. Here's the man. Good mate, how are you?
All right.
Wish you back if you want.
Yeah, cheers.
Oh, that's all right. So in here, I've kept your bacon egg roll and your coffee warm.
Oh, that's beautiful. There you go, buddy.
There you go.
John, this is Adrian.
Well, it is usually us no safety glasses. They're always commenting about it, aren't they?
Exactly. Wear your gloves. Yeah. Once the Pacific Aerials antenna was installed up on the wheelhouse roof, John came back with his laptop to start measuring the VSWR across a broad sort of spectrum of frequencies so we could see the VSWR curve across that spectrum. I have two of these antennas, and this one I'm looking to tune slightly more towards the AIS spectrum, which is a higher frequency, and a higher frequency requires a shorter antenna, so we started cutting it down.
There we go, we can see.
Yeah, right, just the start of the tip.
Alright, so we've got another 5 mil to go.
5 mil before we even get to the wire. So that's just a straight piece of wire inside a glass.
Usually a simple dipole is...
Yeah, right.
Alright, you reckon we got a little bit off it then?
Maybe polish it.
I can just polish it a bit.
Yeah. Do you want to do a tiny bit more or just measure it again?
Let's just measure again. We don't know how much you've taken off.
Should we hold it up again? And
Oh, you want me to hold it up again?
oh, mate, you can be cameraman. I'll do this. I'll hold it.
I'll stand here and pose.
Yeah, I don't think we've actually
Yeah.
touched it. We've still got our resonant point still down here.
Quite low.
150, 152, depending on which way he's holding it at the time.
Yep.
This is our 2-to-1 line. There's blue.
Yep.
We want to be up in this region with our dipping point.
Yep.
Because we're still quite high in the AIS band.
Okay. We took probably about 5 mil off then, you reckon? We've gone to cutting disc from flap disc. Now we've seen the core.
Okay, so we haven't really shifted this point here.
Okay.
But we have flattened, we've taken that sort of weird peak and curve that was up in the upper section here out. So,
should we experiment some more?
Sure, why not?
So this is still our, so the red one is channel 16 or?
The red one is, well, that was where one of our, so we're getting slightly different results because it's not permanently mounted here.
Yes.
So we're doing a number of sweeps, but on one of our earlier sweeps, that was our low point in the curve. But, on the other antenna too, or? No, on this particular antenna, but the green we can see is 156.75, so that's around about channel 16. Channel 16 is 156.800.
Okay, so we definitely want to... And
our AIS band is this blue, which is at 162, or AIS band is the most common, is 162.025.
Okay, that's close at 8.
Probably, there's still a rule there. Right. We did a prescribed measured cut of 8 millimetres.
8 millimetres that time.
8 millimetres, okay.
And where are we at, John?
So I'll retake the sweep a few times because it does vary depending on exactly where it's held.
Oh, give me, make me a smoke.
But it looks like it's moved from just below the 152.5 megahertz to just above there. And looking at that red, that's 153.3 megahertz. So it is coming up closer to us, but our main concern is we want to have the best results on number 2, which is 156, that's channel 16, and we want better results up here. So the idea is we're trying to shorten the antenna, thereby shifting this optimal frequency band a little bit higher up the range.
Okay, should we take a bit more? We're seeing an improvement, but John's suggesting we don't cut any more because
Yeah, because being a dipole antenna, there's two halves to it. There's the part we're chopping, which is the top section of the dipole, but the second part is the ground plane. And you need to have this balance between the two parts. So we're just trying to trim one part to just shift that frequency and flatten the curve slightly. But with the last cut, we're not seeing a significant change in the results. And my concern is if we continue to cut that, we're actually going to have an adverse effect on the antenna. So I think this is probably about the best we can do at the moment.
Yep.
Without pulling the entire guts out of the antenna.
Yeah, exactly.
You know, this is really, but what we have achieved in doing this is we've actually improved the performance in the 162 band. So we're getting closer to our 2-to-1 band here. The way to widen this curve is by having a larger diameter conductor in the antenna. So, you know, we can't physically change that, we're just changing the length. By shortening the length of the antenna, we're increasing its resonant frequency. But, you know, there are risks that we can actually reach a point where we're not going to get the benefit we're looking for. We're actually going to damage the antenna and make it useless.
Cool, thank you. All right, that's good. John said ship it. So now we're going to cross over to our antenna termination engineer.
Oh, it's beautiful. Do I put a bit of...
Yeah, that's it.
Bit of spin on there.
Lovely.
Beautiful. Fully sealed.
So theoretically, it's roughly going to be like that.
That's pretty good. I mean, that
No difference?
I'm getting pretty consistent sweeps. There was a slight improvement in the VSWR, and I'm assuming that's because of the increased ground plane, thereby reducing any background noise being emitted from the boat. Or
So would you suggest shortening the other one? Because it was already a little bit more in that direction anyway.
I think before I proceed any further, I'll wait to get the response from Pacific Ant.
Okay, let's do that.
How to trim their antennas and tune them.
Yep.
But yeah, ideally I'd like to see that curve, you know, reaching its optimum performance around about channel 16 and probably a little bit higher is going to be ideal for your application. But, you know, we are going into witchcraft territory here.
Sure,
So, you know, I think it'd be good to see what the response from an expert in that
Yeah, from Pacific Antennas is, or
Correct.
aerials, yep, okay. This video wouldn't be complete without doing a quick radio check with Marine Rescue. Having a quick look with Marine Radio, if you're in the 3 minutes after the hour or 3 minutes after the half hour, you're not supposed to use your radio for anything non-essential. So if a really quiet sort of Mayday transmission's coming through, that's their opportunity to have the airways clear. Also, just listen that you're not cutting in on someone else's conversation, which we're not. So let's give them a call and see if they can hear us clearly. In order to transmit on Marine VHF radio, you need your radio operator's certificate of proficiency, which I got 2002, so almost 20 years ago now. Marine Rescue Sydney, this is Renko for a radio check, over.
Vessel calling for radio check. This is Marine Rescue Sydney. Marine Rescue Sydney. Can you provide your call sign and your location, over?
Yes, this is MV Renko, and we're located on the north side of Dangar Island, over.
Renko, this is Marine Rescue Sydney. Marine Rescue Sydney. Can you go to channel 78 and call back, over?
Yeah, copy that, going up. Marine Rescue Sydney, this is Renko, over.
Renko, this is Marine Rescue Sydney. We were reading you fair and readable on channel 16 and also on 78, over.
Copy that, thank you very much. Renko out.
Marine Rescue Sydney out.
Then we go back to 16. So, that's actually quite a distance, which is good. We've also got quite a few hills in between, and VHF is line of sight, so pretty happy with that as a good result. Could call Pete, who I'm rafted up to right now. That would have been a bit cheap though. So, we now have good built-in VHF radio, 25 watts on channel 16, and nice big high external antenna that's been tuned. So we've got that side of things covered off for our trip north up the coast. All right, well, take care, and I'll catch you soon when we push on with more of the technicalities of the network, AAS, all that sort of good stuff. All right, take care, I'll catch you soon. See ya. Guess what, Daffy? You're getting up whether you want to or not. You've been sitting in here for a long time. What's going on with your... It's okay, Daffy. There we go. Come on, Daffy. Come on. Come on. Come and have some breakfast. Come on, Daffy. Daisy's eating. Daisy's got breakfast. Come and hop along. Up you get. All right, I'm going to the boat.